with the
no,
impact?
I'm looking at like the key
JT, and he's like, free primary sources and stuff like that.
because I need new ones. I don't know which ones to get. Here, I'll show you which ones.
Five for you.
Yeah, I thought that was fun. You're doing the honestly though? That should be so light.
All right. Does anyone have any questions before we get started today? All right. One thing to note, as I said in at least one email, there is no lab this week. That includes today. Labs will begin next week. There is nothing you need to do to prepare for any given lab. There's no like pre-lab or anything. You show up with your calculator and your notes and your willingness to collaborate with other people. You work with your table mates to accomplish the objective, and then you leave. There's also nothing to do after a lab. So nothing you have to prep before next week. Just show up next week to your normal lab time. But not this week, not today. As for today itself, to kind of reiterate the things we've gone over the last couple days of class, we've looked at scientific method, talked about what physics is, why physics is data focused, since data is as close to measurable truth as we can reasonably get within this universe. So we base all of our findings on the data itself as best we can. So to measure the data, we had to talk about units and unit conversions. Now we have to look at what we're going to do with that data, which is use it in algebraic equations. Now, my goal with this, everyone has a different relationship with math. My hope for this is just to be entirely review driven, just to dust off the cobwebs of the algebra that we'll need for this class. We'll try to go over as many of the different types of things that we're going to have to do in the math of this course as possible. Just get all that review out of the way up front, so that once we start learning about concepts and start looking at physics formulas, we can just jump straight in and start rearranging them as needed. So today, uniquely, is my goal is just going to be review. Today, uniquely, is mostly just going to be math concepts, and that's not going to be what the entire course is like. The course itself is concept driven, and the math is meant to reinforce the concepts. Now, what I mean by that is, in physics, since we like data, we have a lot of formulas, and we use algebras on the formulas to usually try to solve for the thing that we don't know yet. For example, one of the first formulas we will cover is F equals ma, Newton's second law. And for every formula I give you, it's always going to mean something. The no math in this class should, other than the practice that we're doing today, the bulk of the math in this class is going to be about something. It's going to represent something in the physical world. You're trying to predict or calculate a real concept. For example, within this particular formula, every formula will always mean something, by which I mean all the variables stand for a concept, and the formula just tells you how the concepts are related to one another. Within this formula, I can look at this and read out conceptually that if you exert a force on an object with mass, that object will begin accelerating. I think I've mentioned this formula once by now. And this is something that you've noticed before. Object with mass, if you want it to accelerate, to start moving, you have to exert force on it. It's true of everything around you. It's true even of your own body. If you want your own limbs to move, you have to use your muscles to exert force on the mass of your body to make things move. So the concepts here are ones that you're familiar with. But sometimes there will be cases where you need to get a mass moving at a particular rate, and you have to know ahead of time how much force is required to do that. And that's where the formula comes in. And if you don't know something within the formula, you have to use algebra to solve for that thing. Hence, all the stuff we're going to be reviewing today. Any questions so far? All right. Now, to kind of demonstrate in more practical terms, that this right now is an example of the types of questions the math-based questions that you'll get in this class. Let's say that we, with our human muscles, are able to exert a 500 Newton force on a boulder, just for scale, since, at least growing up, I never used newtons and kilograms all that much. 500 newtons, that's about half of what I weigh, so that'd be the force I could reasonably output if I was failing to do a pull-up. And 1,000 kilograms, that's the mass of 5 of me. I'm about, wait, is that right? No, it's like 10 of me. Yeah, 1,000 kilograms is 10 of me. So that boulder is worth 10 of human male. We're going to exert 500 Newton force on a boulder of 100 kilograms, and we want to know what the boulder's acceleration will be as a result. If you exert that force on that boulder, and those are the only factors at play, what's going to happen to the boulder? So, that 500 newtons is a force. That's the force we're exerting, and so that would get plugged in to F in this formula. The mass of the boulder is the 1,000 kilograms, and kilograms is actually the unit we want. I believe I mentioned this on Friday, but physics likes kilograms instead of base grams. It's about the only unit that we want to have a prefix on it. When we put it into our formulas, it's like the one exception. Normally, the formulas want no prefix. This is the one time we want a prefix. So I wrote it as kilograms because we want to keep it in kilograms. This force on this mass, what will the boulder's resulting acceleration be? And if you were doing actual science work, you'd want to know this sort of thing, because if you need to get this boulder to move, you would need to know what output force the machines need to have, right? If your output machine only has an output force of 500 newtons, then, force of 500 newtons acting on a 1,000 kilogram boulder. We plug in everything that we know. We want A. How do we get A by itself in this scenario? Divide by 1,000, very good. Whatever you do to one side, you have to do to the other. So we'll divide both sides by 1,000 real quick. 500 over 1,000 is just going to simplify to 0.5. And then on the right side, 1,000 times A over 1,000. The 1,000s should cancel and just leave us with A. So the acceleration of this boulder should be 0.5 meters per second squared. That is pretty slow. That means that every single second that that force is applied, it would only speed up by half a meter per second for every one of those seconds. So if you apply that force for one whole second, the boulder would then be rolling at half a meter per second, which is pretty slow. And so if you were, a scientist working with some sort of machine crew that's designed to, like, if your work is to move boulders, and your machine that you're using to move the boulders can only output this much force on a common boulder, then all the boulders are going to be moving very slow, and it's not going to be a good time. So you would do this math ahead of time, and you'd note, we need either more machines or machines that do more force. And so that's how the algebra informs the concepts. Make sense so far? Okay. I suppose on the other hand, you can think of this as long as the boulder has that mass and you can output that much force, you can make the boulder move. So it's bad if you're in construction or demolition, but good if you need to move a boulder at all with your bare hands. And so today, there's going to be bigger, more complicated formulas as we go along. And again, I'm always going to explain what they mean, what all the variables mean, what concepts they refer to. And it's not going to be an entirely math-driven class, but we can't really avoid the math. So I want to make sure to practice it now so that it all makes sense as it comes up later. So to that end, the math is all going to be algebra-based in this class. I'm not going to have you be doing calculus. And to do algebra, one must remember the order of operations. This whole thing, is this unfamiliar to anyone in the room? Just to check. All right. So just for review then, PEMDAS stands for parentheses, exponent, multiplication, division, addition, subtraction. reminds us the order in which to perform math operations upon an equation. And so let's practice that very briefly, just to make sure that makes sense. I've got two math functions on the board, and I'll leave you guys to it for just a minute to work either on your own or amongst yourselves to determine what the answers to these are, and then we'll double check in a sec to make sure that the order of operations works for you. That's not a good sign. Alright, how you feeling so far? A couple thumbs up, good to see. Alright. Now, I'm in the personal habit of usually rolling the board up to write on top of my projection. So for this one, I'm just going to write right here, and then for the other one, I'll start at the end of their end of the board, because this one's just gonna need more space. All right, first up, we've got 5 numbers and 4 different operators sitting between all of them. Order of operations tells us, first, look within any parentheses, which there are none, so that step's over. Next, do any exponents. There are none, so that step's also over. Next is multiplication division. And one thing to note about this method is that the M end of the D and the A end of the S carry the same weight, which is to say, you can do multiplication and division at the same time, as long as you do them before addition and or subtraction. Which technically means you could write this as PEDMAS or PEMDASA, but they arranged it this way so that it spells out something resembling a word. But the multiplication and division take place at the same time, as long as you do all of them before the addition and the subtraction. So, within this, 8 divided by 3 takes priority over anything minus 7, and 2 times 5 takes priority over 7 being added into the 2. So, what is 18 divided by 3? Thank you. Minus 7 plus, and then the 2 is being multiplied into the 5, which is, thank you. Still good so far? All right. Now, just like how multiplication and division have the same priority as each other, addition and subtraction have the same priority as each other. So all that's left is addition and subtraction. We don't have to be very careful anymore. We can just proceed from here. So what's 6 minus 7? Very good. What's negative 1 plus 10? Positive 9. Very good. So final answer for that one's positive 9. Does anyone's work disagree? All right, good to hear. Now, let's look at the other one. The other one is a big fraction that has a few unknowns in it. There's a few x's and y's. We know that every x should be a 1 and every y should be a 5. So I've written the fraction out over here with the 1s and the 5s plugged in, and I'm just going to work that way. This one just takes up space because the fraction is very physically large. Any questions or issues with this before moving on? Okay, so to consult the order, first we look within the parentheses. There's 2 very large parentheses here. We've got a big parentheses above this division line and then a big parentheses beneath it. And what that really means for what we have to do here is we have to figure out what this big thing is and what this big thing is before we can do the division. So we've really got one big ugly fraction here. We have to figure out what the top is and what the bottom is before we can process the fraction. That's what the order's telling us in this case. Within each of those parentheses, we need to do the exponents first. And when doing exponents, it's always worth noting very closely what number the exponent is attached to. This exponent, this squared, is attached to the y, and the y happens to equal 5. This exponent, the 3, is attached to this x happens to equal 1. So to do this correctly, you need to make sure that you are only squaring the 5 and cubing the 1. You should not do 1 times 5 and then, well actually that would still give you 25, wouldn't it? But you definitely shouldn't do 1 times 5 and then cube that, because that would give you a very different answer. So, the exponent only ever operates on what it's directly attached to. So, to handle the exponent stage, 2 times 1 minus 4 times 5, 1 times 5 squared is 25. 3 times 1 minus 6 times 5. What is 1 cubed? 1, very good. 1 to any exponent is 1, except 1 to the, never mind. So that's the exponent step done. Next is the multiplication division step. I'm going to hold off on the division for a minute. Instead, let's just get all the things that are being multiplied into each other done and out of the way. And a lot of things times 1 in this case. 2 times 1 is 2, minus 4 times 5. What is 4 times 5? 20. And note that negative sign remains. You can either think of it as a negative 4 times 5, which is negative 20. You can also think of it as positive 4 times positive 5 is positive 20, and positive 20 is being subtracted from 2. Point is, that negative sign needs to remain. And then on the underside, 1 times 25 is 25. 3 times 1 is 1. 6 times 5 is 30. Again, same thing with the negative there. And 1 times 5 is 5. So I'm going to leave the division for a minute. I wanted to show how the multiplication worked out. Feel good thus far? All right. Now, at this point, you could kind of take it in 2 different directions because technically the order does say multiplication and division happen at the same time. But in this case, the division is occurring to a subtraction in kind of both parts, actually. So that kind of gives us 2 ways to proceed from here. You can either do division and turn this into a fraction minus a fraction, like 2 over 25 minus 20 over 25. And then you'd have 2 fractions that you're adding together, or I guess subtracting. And I'll show what that looks like. So you could go that way. But you'd end up at the same place if you just did the subtraction on top first, ultimately. You could kind of think of the subtraction as within its own parentheses because doing it first doesn't really hurt anything. So to show what that would look like, negative 18 over 25, negative 27 over 5. And note, they mean the same thing. Because these 2 fractions, 2 over 25 minus 20 over 25, do become negative 18 over 25. Same with this one. So whichever way you choose to think of it in this particular case is valid. The order of operations does say division first, but because the subtraction above the division line is kind of isolated, you can do the subtraction part first if you wanted to. Sometimes the order of operations is a little flexible if you know what you're doing. So you could go from here to here, but this would still end up here eventually anyway. So I'll just draw an extra line. Does that feel all right? Okay. Now we have a fraction divided by a fraction. And once again, we kind of have 2 options with how to proceed. I'm going to go with the method, the order of operations literally advises first. Because we've got a lot of division going on. We're going to process it as division first. That's what I'm going to demonstrate first. Negative 18 over 25 is, I believe, negative 0.42. No, 0.72. I got my examples mixed up. And then negative 27 over 5 is negative 5.4. And then we can just treat it as one more division and get 1.3 repeating. If you put that in your calculator correctly. Does anyone have any issues with me erasing this one? I'm kind of crossing into my old work. So again, if you put that in your calculator correctly, it should say 1.333333 for as many digits as your calculator tends to spit out. If something repeats infinitely, you can just represent that with a line above it. It's not something you have to do in this class, it's just something I might do on occasion, so I want to make sure that I've just at least explained that once. And math fraction. In this particular case, it gave that infinitely repeating fraction because we can actually change that to 2/15 if you prefer to write it that way. And that is one correct way to get to the final answer. How's that feel? Yes.
We got, 0.14 to 74.
0.14074. Mind if I take a look? It's all right. Let me use that as a springboard real quick to mention that it's always a good idea to write down your work in this particular course, and that's why I'm going to always show my work on the board when applicable. Growing up, I always hated showing my work in a math situation because usually I could skim to a number straight in my head, and I just wanted to write that down. I didn't want to have to backtrack to write all of my work down because it just felt like a waste of time. And if you feel similarly in math situations, I get that. However, I want to try to change your perspective about showing your work in this particular class. It's not not every question I give you on a test is gonna be math focused. Like, some of them will be inescapably, but there's gonna be some math. And when you're doing math in this class, you should always write down your work kind of as a safety net. Because even if you can do the math for something in your head, like some of the formulas are pretty short. Like, if you can do this in your head, great. However, even if you just jump straight to net force equals 50 and you write that down, like, if the correct answer is 50, you'll get your points. However, showing your work in this class is your safety net in case you made a mistake. Because I give partial credit for everything you write, even frankly on short answer questions. Like, everything you write is worth points, and if you're showing your work for something, I'm looking at your work more so than I'm looking at the final answer. Because if you did every single one of these steps, and maybe you just didn't write down a negative sign at some point, and you got negative 0.13 as your final answer. Since you showed all the work and I can see what tiny thing you did, I'd give you 9 out of 10 points for that. Just one small point at the end for just one small algebra mistake. And 9 out of 10 is still an A in this class. So you can get an A on a test without ever getting your math totally right, as long as you get it mostly right. And you show all the steps and I can see that you know what's going on. But if all you wrote was negative 0.13, I don't know that you understood what was going on and only made one small mistake at the end there. I don't have any work to check to know that you understood what was going on. So it's not that it's not even an anti-cheating thing, it's just that I want to see that you know what's going on, and if you make a mistake, the work is the only way that the only backup option for me to give you the points you earned. Does that make sense? So you should show your work on any relevant math questions in this class. And I mean that as an encouraging thing. You will get points for everything you write down on my tests. Even if it's nonsense, even if it's not correct. Writing something is always better than writing nothing. The only way to get a 0 on any of my assignments is to leave it blank. A smiley face is an answer, even if it's not the one I wanted. It's not a good answer, but it's something. Does that sound all right for now? All right. So, math is unavoidable. Show your work. There's a few more math things I want to practice real quick, and then we'll call it for today. First off, I want to note a quick quirk about this last step that happened here. What I showed here was solving each of these fractions and then solving the final fraction, but there was another way that that could be written. If you're following along with the notes that I post, what I'm referring to is dividing by a fraction is mathematically the same as multiplying by the inverse of that fraction. The example given here is 9 over 3.2 is the same as 9 times 2 over 3. In this particular case, what that means is if you wanted to do this a slightly different way, you could write out negative 18 over 25 times 5 over negative 27, and that would be the same thing. And in this case, you would then multiply negative 18 times 5 and 25 times negative 27. When you're multiplying fractions, it's always top times top and then bottom times bottom. Don't get that mixed up with cross multiplying. Cross multiplying happens if there's an equal sign between two fractions. This is two fractions multiplied into each other. 1/2 times 1/2 is not 1, it's 1/4. Does that make sense? So doing this would get you to the same point. You get a big number over a small one, and it would still simplify down to positive 2 over positive 15. There's a whole slide here within the notes about just tips when dealing with fractions. Note that that trick doesn't work for cross multiplying, which is a different thing. It also doesn't work for fraction addition. Fraction addition requires the least common denominator thing. So these notes are a good resource, honestly. Again, I post all my slideshows to Brightspace, so if you're ever working on math parts of your homework, you can refer back to these as well. Now, I did mention that the math in this class is always meant to inform the concepts, and the way that you're going to be using a lot of the formulas in here will typically involve solving for an unknown that's buried within the formula. I showed earlier with f equals ma, say you know two things, you have to solve for the third thing. So often, rather than one full equation with everything known in it, you will have to rearrange. You have to perform algebra, take things from one side, send them to the other to eventually end up at x equals something. And that requires the order of operations, but also in my opinion, slightly modified way of using them sometimes. So I want to go over that briefly with just a few examples. I've got a 1 on the board there, 5 times, open parentheses, 3 minus x squared, close parentheses, equals 10. Any complaints if I erase the big fraction? So here's our formula. Let's think of this as a physics formula with everything plugged in. We're just trying to solve for this one unknown concept here. And the goal would be to get x equals number. Now, I kind of find that it helps to think of this as dismantling one side. Like we have to send things from one to the other to leave it at just the one thing we want. Sometimes I also tend to think of it as using the order of operations, but backwards. Sometimes I might refer to that as SADMAP. Mainly because if we look at the order of operations front ways, first comes parentheses, which our x term is trapped inside of. We can't really simplify the parentheses any further because we don't know what x is to proceed. And the next term is exponent. X is squared, but we don't know what x is, so we can't actually work that yet. And so, like, we can multiply the 5 in, but that still doesn't get us to the x. Instead, we have to dismantle things, send things over one at a time, and again, sometimes that might kind of reverse the order, because you have to take each element that isn't the x and send it over. What I mean is, if we kind of look at the method backwards, what needs to be added or subtracted from one side and sent to the other? That x has that 3 being added into it, but that's still within the parentheses, so we can't get to that yet. What needs to be multiplied and divided away from this particular side? Exponents and also within the parentheses. So that x is buried within several operators, and we have to strip them away one at a time. Can't deal with the parentheses yet, can't deal with the exponent yet. So the first thing we can get rid of is the 5. Yes?
So we should divide by 5?
Yes, we should absolutely divide by 5. And technically you can multiply the 5 in and deal with it later, but I like to divide by it and just send it away as early as possible. And I suppose actually the main thing that you should remember is, again, this is entirely review. Whatever you do to one side, you have to do to the other. So if we divide this side by 5 to get rid of it, the other side gets divided by 5 as well. And so that should leave us with (3 minus x squared equals 2). And now we can get rid of the parentheses and proceed from there. And kind of thinking about the order of operations backwards, add, subtract away anything that isn't the x term, get rid of anything that's being multiplied, divided into the x term, and then deal with any exponents on the x term. Again, it's backwards kind of. So we got a positive 3 over here. How do we get rid of it? Very good. Minus 3, minus 3. So that's going to be negative x squared equals 2 minus 3 is negative 1. What next? We can divide both sides by negative 1. And note, that negative is not really a part of the x. That negative is not within the square. This is, again, kind of looking at the order backwards. First we dealt with the addition subtraction. Now we're dealing with the multiplication division. And right now this is x squared times a negative sign. And we know this because the original equation was 3 minus x squared within the parentheses. That negative is not attached to the x, it's kind of out front of it. And if you divide both sides by a negative 1, that'll get rid of that negative sign, so we can continue working backwards to get to the exponent step. So on this side, negative 1 divide, it'll cancel out the negative in front of the x, and then kind of the same thing over here. Negative 1 over negative 1 is just positive 1. And how do you get rid of a square root? Sorry, how do you get rid of a square root? I kind of spoiled it. But again, whatever you do to one side, you have to do to the other. So square root of x squared equals square root of 1, and x equals 1. It's always a good idea to double back and check your work. So I'm going to take that 1, bless you, and place it right here, just to make sure that everything works out. 1 squared is 1, 3 minus 1 is positive 2, positive 2 times 5 is 10. How's that feel? All right. questions or concerns with this level of math? All right. That's pretty much all that's the basics of the math that's going to be in here. You're going to have a formula and you have to solve for one thing within the formula. I'll always make sure you understand what each letter within the formula represents so that it is more concept driven. Again, to kind of tab back to the types of math questions we have. They're usually more like a logic puzzle or application of a concept than it's just number crunching repeatedly. So it's usually more like this and less of this. So if you're trying to gauge what you will be seeing more on your homework and on tests, math questions will look more like this. Applying a formula to a scenario, solving for the one thing in the formula you don't know. So to get just a tiny bit more practice for that before we break, and to make sure that there's absolutely absolutely. There is already a slightly outdated formula sheet on Brightspace. It's outdated in that it refers to the chapter numbers from a textbook I used to use instead of the current one. So I'm in the process of reformatting it. But you will absolutely have a formula sheet. There is a class formula sheet that you can use on every assignment, tests and exams included. You don't have to memorize them because I don't have a couple of them memorized. Like if you were a physicist, you'd have a reference book on your desk. You'd have a formula sheet I have formula sheets when I do things, so I'm rambling at this point. You will have a formula sheet. You don't have to make one yourself. You can print off the class copy and scribble all over it, frankly, as long as you don't have the answers to the test written on it somehow. Does that answer the question? Any other questions before one last thing? All right, so again, with this being the type of question you'll see in mind, let's just speed through a few more, I promise, quick examples. I've basically gone ahead and plugged numbers into formulas here, just because you don't know the formulas yet, and it would take time for me to explain to you what all they mean right now, and we're going to get to it later anyway. So these are based on real formulas, and I just plug numbers into them at the start. And for each one, there's just a couple math things I want to make sure that you note before we move into physics concepts. First up, 60 equals 0.5 times x over 2 squared. So, getting x, what's the first thing you think we should do? Divide by 1/2, very good. So over 0.5 over 0.5. Note that that is basically the same thing as multiplying by 2. So this does not simplify to 30, it simplifies to 120. Check it in your calculator if you want to. 60 over 0.5 is 120. 0.5 over 0.5 is 0. And that leaves us with x over 2 squared. Note that only the 2 is being squared, so that's just going to become 4. And what's our last step? Very good. So that should be 480 equals x. Multiply by 4. 4 times 120 is 480. Questions, concerns? All right. That, again, as the semester goes on, I'll point out how this kind of resembles the centripetal force formula that we'll cover in 2 months. This one is kind of meant to resemble a momentum collision formula somewhat. Here we've got 5 times m plus 20 times m equals 4 squared minus 8 times negative 9.8. There's a particular math property that I want you to remember here. Do you know what it's called? Say it again. That would work. We could divide this whole side by m. That would cancel the m's and send it over here. So that would work. My intended thing that I'd like you to remember here is called the distributive property. Well, actually, no, man. No, I think I see what you're saying now. Because my idea is pull the m out of these two terms, leaving behind what they're attached to, and yeah, you divide it by the like terms. That just might be a different way of describing this. This is what I was intending to show. Does this make sense? All right. I call it the distributive property. But dividing by like terms absolutely describes what happened there. So thank you. Main thing again I want you to remember is if you see two things with the same variable in them, as long as that variable isn't like being squared in one and not in the other, they can ultimately be added together. You can either add them directly or using the distributive property get m times 5 plus 20, which would eventually just become 25m. On the right side, 4 squared, again, exponent takes priority over anything else. Exponent is applied only to this 4, so that's just going to be 16. And then minus 8 times negative 9.8. Positive, is that 72.2? I don't remember.
$78.
Nope, the negative times the negative becoming a positive. So 5 plus 20, 25 times m. So I've just written that as 25m. 16 plus 78.4, 94.4. M equals 94.4 over 25. 3.776. That would make sense? Feel good? Alright. And took up more board than I was expecting. That's fine. Last one of the day. That last equation there is meant to resemble one that we will cover fairly soon in the course. Try to show it very briefly. This formula is for tracking an object's displacement, basically where it is over time, assuming that it is both moving with velocity and or accelerating. So it's a very good formula for just motion in general. It's one of the first ones we're going to cover. And in this particular case, an object has moved 15 meters backwards from where it begins. Its initial velocity is 0. Its rate of acceleration is a negative 9.8. And we do not know how much time has passed. We would like to know how much time has passed, so we have to solve for t. Now the wrinkle here is, there's a t in 2 different places, and one of those t's is squared. And that means that we cannot do the same thing that happened here, because there's a different exponent on each of those t's. Sometimes this might end up in a quadratic, which if it comes up, we'll review that later. One thing I want you to note right now though, do we have to do a quadratic here? No, why?
Because the t times 0 is going to be 0, so we can just cancel out.
Exactly. T times any variable, even in an unknown that you're after, times 0 just goes away. And that kind of gets rid of the issue of the t being in more than one place. And then 1/2 times negative 9.8, I should simplify that to negative 4.9 t squared. So note your zeros. Sometimes things cancel out and it just makes your life easier. So negative 15 equals negative 4.9 t squared. Is just getting rid of the zero completely. That zero ate the t, and then now that it's being added, subtracted into something, it just doesn't accomplish anything, so it just goes away. How do we get t by itself? We will take a square root. However, since we're dismantling, we need to kind of think of the method backwards. So before we can get to the exponent stage, we actually have to get rid of what's being multiplied and divided into it first. Again, this is only if you are trying to dismantle algebraically one side to get something that's buried within it. So I would actually first recommend dividing by negative 4.9. This is what I wanted to review today, and it's okay if it takes the whole semester for it to feel fluid. I promise it'll make sense if it doesn't yet. Question? Or was that just a hand up? That's fair. Honestly, if you teach long enough, any hand motion like triggers question, swirl. So negatives cancel. I don't know what 15 over 4.9 is yet. But then you can take the square root. Since the negatives cancel, we would not end up with an imaginary number. So, I just wanted to kind of demonstrate to you what a cat needs to be aware of in these last 3 months. How do these feel, and does anyone have any questions at this particular time? Alright, that should be the worst of the algebra you'll commonly have to deal with in here. And again, it's not an entirely math-focused course. I want to make sure you've seen it all before we started using it. Friday, we'll start on some concepts, namely Newton's laws of motion. And let me know if you have any questions till then. Please have a wonderful day.